Hello, and welcome to our Knowledge Nugget series. Today, we are going to explore the costs and benefits of smart manufacturing solutions and their evaluation. In the era of digital transformation, smart manufacturing has arisen as the fourth industrial revolution to increase productivity and efficiency, altering the operational landscape for businesses across diverse sectors. This paradigm encompasses different technologies like the Internet of Things, IoT, artificial intelligence, AI, big data analytics, simulation, cloud computing, system integration, augmented reality, cooperative robots, additive manufacturing, and cybersecurity. Despite the undeniable appeal of such technologies, companies and businesses before initiating a project are interested in its outcome in terms of costs and benefits. Consequently, in this session, we intend to address the following questions. What are the benefits of smart manufacturing? And which costs are associated to smart manufacturing? Let's go. Before delving into the details, let's try to understand the reason why knowing the costs and benefits of a technology is considered relevant. It allows companies to evaluate the feasibility of a project or decision by comparing the expected costs and benefits associated with it. This is an analytical process applied across various fields to make an economic evaluation. Costs and benefits are related to the number of resources, human, hardware, and software involved in the project. If costs are quite simple to be measured, it cannot be said the same for benefits. Indeed, their measurement is much more complex due to the nature they can assume. Benefits might be measured in terms of possible savings and in terms of possible extra income and can be both tangible and intangible. Whatever the specific technology, every smart manufacturing project aims to achieve the substantial goal of improving the management of knowledge, data, information, models, documents, etc. along industrial processes. This improvement can take different forms, depending on the context in which it is declined. For example, it can correspond to an increase in the punctual efficiency of activities, through which to compress time to market and slash or lead time, rather than an improvement in the quality and reliability of products and services. Digital applied to industrial processes almost automatically enables a more structured, controlled, and at the same time collaborative working model which, if adequately supported by organizational interventions, can allow important productivity recoveries. For example, by eliminating non-value-added activities, such as redundant transcoding of data and information, as well as the possibility of virtually eliminating geographical barriers, making it possible for actors located around the world to work as a team. In particular, for digital engineering projects, modelers, simulators, PDM/PLM, and the like. It is empirically proven that these kinds of systems always activate virtuous circles of process and product improvement. The adoption of factory information tools, from MES software to schedulers, as well as more strictly automation technologies, such as collaborative robotics or even computer-aided production, always brings with it tangible productivity benefits: less downtime, consequent reduction of setups and lead time, greater use of resources, better timeliness of production and logistics processes. In addition to these, the ability to control and measure production performance can only grow, making factory management more transparent and responsive. On the other hand, costs are easier to define and normally identifiable with a critical evaluation of the supplier's offer. There are three types of costs for smart manufacturing projects: installation costs, implementation costs, and maintenance costs. Most of these projects belong to the category of investment plans with a high impact on the organization. These are projects that, even in the simplest senses, such as the installation of a CAD, involve and slash or allow an important revision of the processes and the way of working of the people involved. For these reasons, it is more important than ever to manage the organization of the digital transformation process in the best possible way, defining a clear execution program and identifying a priori the costs and benefits that can be obtained on which to monitor the results. It is also important to carefully evaluate the scope of the project, the impact of the solution on the business, as well as the usability of the tools introduced. Installation costs consider all the expenses associated with the purchasing of software licenses and hardware equipment needed. Thanks to the evolution of architectures and infrastructures towards the cloud, In the licensing of manufacturing systems, as a service and pay-per-use supply methods are becoming increasingly widespread. This shift significantly changes the curve of the economic flows of digital investment. Implementation costs consider all the expenses that the client company must face to make a smart solution operational and usable. They include the customizations that the company often has to request from the system provider to adapt the solution to the company's operations, the analysis and eventual migration of data from old legacy systems to new systems, as well as the eventual training of users. Maintenance costs consider all the expenses associated with the preservation and continuation of the functionalities provided by the implemented technology. These costs involve activities and resources dedicated to updating and upgrading licenses, inspecting, repairing, or replacing installed equipment and devices to prevent breakdowns and maintain optimal performance, vendor support and maintenance contracts, if any. In the realm of smart manufacturing, understanding the cost structure is essential for strategic investment. Our costs are categorized into software, hardware, implementation, and administration, with an overall maintenance fee. Software costs encompass licenses for servers and users, along with application installations on individual PC. Hardware expenses cover the physical servers, any additional or upgraded user terminals, and our networking infrastructure. These foundational costs ensure that our smart systems operate seamlessly. Implementation costs arise from integrating smart solutions into our current practices. This involves analyzing our systems, customizing solutions, migrating existing data, and training staff to adeptly handle new technologies. Administration costs involve the continual oversight of these systems, including the justification for the chosen systems, re-engineering business processes for optimal efficiency, and routine system administration. Lastly, maintenance costs, which are a percentage of the combined software and hardware expenditure, are pivotal for system longevity and efficiency. By understanding these expenses, we're set to make informed decisions that will drive our manufacturing processes towards greater productivity and innovation. Summing up the knowledge acquired in this nugget, the tools of this technological context increase companies' productivity, allowing cost reduction and information sharing along the value chain. Moreover, they are not limited only to the manufacturing sector, but are indeed nowadays present in several areas, such as medicine, advertising, entertainment, architecture, construction, etc. Anyway, such analysis represents an important part of the decision to implement a smart manufacturing solution.